three axes, suppose E1 cap, E1 T cap. This is E2 cap. These are the three axes in x, y and z direction, and this is called eigenvectors, and the values in this direction is lambda 1, in this direction is lambda 2, in this direction is lambda 3. Tensor can be represented lambda 1 E1 E1t plus lambda 2 E2. This is a presentation of tensor. This is a slightly different representation in terms of, in place of x, y, z, now we are talking about eigenvectors and eigenvalues. For 3-dimensional it has 3 components. For 2-dimensional it will have only lambda 1 and lambda 2, because then E3 will not be there.
It's a tensor?
Yeah, this is another representation of a tensor in terms of eigenvalues and eigenvectors.
How you can match this presentation with another presentation with II and IJ and in the last presentation I asked a question about why you use E1 and you don't use E1, E2 or something like this.
I use II, IJ
for eigenvectors, eigenvector and eigenvalue. You use E1 and E1 for one entry. Why you don't use E1, E2 or E1, E3? And what is the?
Is it still recording? It's just for 30 minutes, right?
Is there any proof that these 3 parts cover all the space, or?
I got it just in the paper. This representation, wherever I have seen the tensor theory, at least 4 or 5 books, at least 10 papers. This representation I got is only in this one.
Yeah, but I guess the most important part is not just combining results from many papers, but more importantly, like you understand what is that for this stuff. So I don't know. I mean, how many slides do you have? I don't see any point if you don't understand anything.
No, sir, I'm trying to explain this thing. This is a different kind, a little bit different presentation of the same tensors.
Yes.
Means it's similar to that one, but not exactly like II, IJ, IK. It's a little bit different presentation of the tensor.
But I guess I have learned this like how
For to understand,
after don't know how to get from that pixel into a tensor. Without that part, I guess it doesn't, because I guess afterward the procedure, I remember that, like you mentioned that in the previous talk. I feel happy with that. I mean, like it's okay, it seems intuitive, like the tensor voting, if it's farther away, it will has less effect, less influence, and also it will depend on it will pass based on the angle also and stuff like that. But I guess the key is really here, like how you convert whatever your data, that the image, how it suddenly becomes tensor, and why tensor voting.
that is a good question. Yeah. And that was my basic problem, that I was not getting the MATLAB code, how it's converting the pixel into a tensor. Because even in the code, he has taken not directly the image file. He has taken some self-made banana1.h file, which is not a JPG image or not another kind of image. It's just a coordinate and 3 values, you can say. It's taken like this.
I think we have here some So the question is about how to calculate the magnitude of a tensor and the trace of a tensor and stuff like that. So it's a little bit different.
Similar to Frobenius.
But you want to put these equations on the board, maybe?
Vector. I think linear tensor is nearly similar thing. Half T. Okay.
The similar to Frobenius.
Yeah. Half. Tau.
Transpose.
Transpose.
This was the magnitude.
But this is a tensor of rank 1, I guess.
No. Tensor
Of
rank is
rank
vector.
2, sorry,
Rank
2.
Yeah.
Yeah.
So there are 2 factors.
Tau is a tensor?
Yeah, tau is a
Yeah.
tensor.
It means it is nothing but a matrices of 3 by 3. It is matrices transpose and they are multiplying.
Actually, tau is the magnitude of the tensor.
No, tau is a tensor.
Because here, see, look at that.
Okay,
Well,
then you have a magnitude
See,
sine.
but it's equivalent to this, though. So is the magnitude of tau is tau.
Okay.
Actually, even this is a little confusing. The representations of
Okay,
all
so
these
sorry,
tensors.
so just for this one here, but the scale.
What's the trace of a tensor?
They say if it's a matrix.
Okay, this point I will leave. I will discuss on Monday. I will try to understand more better how we are converting a pixel into a tensor. The rest of thing I have actually already discussed, but let me give a brief idea of it. How we did, how we will do it. Like if we have 2 vectors and we have to find out the resultant at a third point, what we will do? We will take the impact of this vector here, called the component of this vector. Again, the component of this vector here, and then we will add, or vector sum. Similarly, we can, like a vector can be divided into 2 components, in x direction and y direction. And what we can do, this component and its x direction component we can add. Y component and the y component of other vector we can add. In this matter we can find the resultant of 2 vectors. Here we can, suppose this is our tensor. We can convert or resolve a tensor into 2 parts. One is called ball tensor, one is called stick tensor. Because stick tensor gives its orientation or the length, and the ball tensor will give in which direction it is going to orientate. So these 2 components, if we have, so for each point the tensor is divided into 2 parts.